Okay, so good evening, gentlemen. So I'm recording. So it's recording. Today is the 2nd of February, 2016. It's Tuesday. So I'm just doing a tutorial question review. So now this question that we are looking at is tutorial 6, question number 9. Okay, so you don't have to copy the question. The question is really inside your booklet. But I write it here just for completeness. Also good for the video so that when people see, they know what question we are looking at. Okay, so just repeat, tutorial 6, question number 9. This one is topic 6. Topic 6. Okay, so the question I will just read for completeness. This particular question is about 8-bit DAC. DAC stands for what? Digital to analog converter, right? So, and it says that it has an output current of 16.2 milliampere. Okay, so in our context, we'll either give you current or voltage. We'll calculate it. Right, so when 16.2 milliampere output, when the digital input is this digital value, okay, 10100010. So this is a binary number. Okay, so there are two parts of this question. Okay, so we need to work out one by one. So the first one is determine the expected output. Okay, when you are given a digital input, binary input of 1000. 1010. Alright. Okay, so step number 1. What should you do in the very first step in the solution? Okay, so step 1, what you should do really is to, first of all, my advice, my suggestion is that you draw a digital scale. Okay, then and on the side of it, you draw also an analog scale, which is a current in this case, because it says current. Right, over here, output 16.2 milliamps. So you should get a hint already. This one is the current scale. Now, maybe first thing first, right? Now we need to help ourselves, okay? Because we need to know you are given some current, which is 16.2 milliamps somewhere here, right? Now you are given a binary equivalent, okay, which is 1010. 0010 base 2. Now step 1, because we need to use the information that is provided to us. So first step 1, after drawing the scale, you need to find out what is this decimal equivalent number for this binary input. Okay, so I overheard you all were saying it's 162, right? This one. So the decimal equivalent is 162 base 10. Okay, 162. Right, so now this 162 in decimal is equivalent to a current of 16.2 milliampere. Right, so here is the digital scale, here is the analog. Now, can somebody tell me what is the maximum here? How many bits is this, by the way? How many bits? How many n? N is what? 8 bits, right? 8 bits. So what is the maximum here? This one. Because here is 0, What is the maximum here? Can somebody help me? 255. How you get 255? Because it's what? 2n minus 1, right? For this one. Okay, so here by right is 2n. Because if it's the maximum, that means you have all the ones, right? 1, 2, 3, 4. Am I right? It will be all ones. And then here will be 255. Don't forget to subtract by 1. So 2n minus 1 will be here. Right? You agree? 2n minus 1. Because you start from 0, right? So 0 to 255. Total, there are 256 steps. So you must remember. Okay? Now, so what do we do next? We need to find out what is the single step, right? Which is this thing called a K. Okay? K, step size. K stands for step size. We need to know what is K. What is the K is step size. Okay? Called step size. So we need to find out that. How do we find the step size? Anyone? How to find the step size? So in order to find K, right, I'm going to write here, K equals to your this current, 16.2 milliamp, right, divide by 162, right? Divide by 162 to give you the K. Okay, because you take this value divide by this numerical number here, 162. So you get the K. So what's the answer, K? Can you give me in, is it, what is 0.1? Unit? Milliamp. Okay.
So if you opposite that how also can.
Huh? What do you mean? No. K must be a, K has a unit, no? K is a factor that has got units. Okay, so you take 16.2 milliamp divided by 162. Huh?
K unit ampere.
16.2 divided by this one, 0.1 milliamp.
Ampere the unit.
Huh?
For K.
K, this one ampere?
K got no unit one, sir.
Oh, unit.
Got it.
This K is different from the K.
Which K? Huh?
The K.
Huh? Which one? Which K? This one DAC. Which one? Are you all saying something else?
No. So you think too far.
Huh? Oh. Okay, trying to understand what that question was. But okay, is it okay this one? So this one. But that's not the end of the story yet. So what's the next part? Not finished yet, not finished. We just found the K only. So you are asked to find what is the expected output. Okay, for this, you are given a new this new binary number.
Sir, for the K, right, you put 0.1 milliamp, right?
Yes.
Do you need to put like 0.1 milliamp like
Per no need, because this one is just a numerical number 162.
okay.
There's no units for 162, right? Right, but the top unit milliamp must still appear.
Okay.
Oh, understand? So okay, what is this now? Your question now is that you are given another. This one is lower, right? A lower value here. So you are given some new binary number as shown over here. Am I right? This one is here. What's the decimal equivalent? Can somebody help me? 138. I'm hearing. This one is 138. In decimal, right? So what is the equivalent here? Should be quite relatively clear, right? I think. What do you get? How do you get this value? Because you already found one step already, right? So now this fella here is 138 steps up there. So what do? You take 138 times K. Okay, because K is the one step. But this is 138 steps, right? This point here, this digital scale. So I think it's easier. If you all do it this way, it's very easy to see. I mean, this is I also tell my full-time student. So they do it this way. So to answer your step, just now the question part 1 haven't finished yet. So for this digital input, okay, you can write the digital input, right? The digital input of this the question 1000 1010 base 2 equals to 138 base 10. I put the subscript here to say that it's the base 10 decimal number. This one base 2. So then that digital the expected output. So you can write down the expected current output. Okay, expected or output current also can. Okay, expected output current, okay, equals to 138 times K. Okay, and that gives me some value times 0.1 milliamp, right? So the answer would be 13.8 milliamps. Any question so far? I would strongly suggest you go through this one thoroughly, this question. Okay, so therefore I purposely record this video. Very important. Okay, thoroughly go through this question and have a very full understanding of this question. Okay, very important as I hint to you. Okay, exam question may somehow be in this form.
Don't see if anybody watch our video.
Yeah, that's why I want to highlight the video. So I will emphasize. Okay, please watch. Okay, so you Cannot catch it first time, never mind, later the video is there. Catch it again at home. Catch it a few times. Okay, very important. Huh? Ken, is it clear? Did you understand? I think I would strongly recommend you all draw a 2 scale here. Then it's very easy. So if I even ask another question, right? What is the full scale output? Can you calculate? I'll never ask here. What is the full scale output current? 25.5. So what do? You take 255 times the K also, right? You will get the maximum output. Okay, as an additional question. Okay, but I'm going to explain the part 2, which I'll let you all finish this part first. So I'm going a bit slow to explain step by step. Okay, step by step. Okay, so again, repeat. So first of all, step 1, draw the 2 scales. One is the digital scale here, and draw at the analog scale. In this case, is the current. Okay, so first of all, identify how many bits. If it's 8-bit, you write down 8-bit. Then you need to know how many. The maximum is 255 because it's 2 to the power n minus 1, right? So it's from 0 to 255 because this one is an 8-bit system. Okay, then likewise, you will draw the analog current here. So this is the full scale. This is the analog output scale. Okay, so you will find the K first. Always find the K. K means step size. Find what is the step size. So then you draw something like that visually, you can see. Okay, then you find the K. After you find the K, things will be very easy already. Okay, whatever they ask you to find, right, you just take this one times the K. Okay, so that will give you the answer. So your K that we found in this question is 0.1 milliamp. So now you are given another new set of digital input, okay, which is this one here, 1010, right? So it goes to 138 decimal. So you need to use calculator to convert if you want. Use your calculator to help you. Okay, then the expected output is this digital value input, 138 times K. So you get this 13.8 milliampere. That's the first part. Okay, now maybe we can proceed to the second part. I want to keep this board here. So what I'll do is I'll try to put continue from here, the solution here, okay? But I think the video recording still is quite okay. I think should be able still can capture it. Okay, now let's continue on. So it says that this one has a full scale error. What does full scale error means? 0.8%, plus minus 0.8% of the full scale. Now this full scale error thing, don't get too very worried. It's like your resistor, right? If I tell you a 10K resistor, are you sure it's 100% 10K value? Cannot be, right? So what is the tolerance band for? The resistor. The strap, remember the gold, silver strap, right? Remember? So what? Silver is how many percent, for example? You remember? Can you remember? 5%. Silver 5%. Gold is 10%. So which one better if I ask you? Gold or silver? 5% better or 10% better? 5% better, right? Because smaller error, right? Okay? 10% means bigger error, right? So you want a smaller error, right? So the percentage smaller, the better. So likewise, same thing. Now, if this thing full scale, you must first of all calculate what is full scale first. Then you take the error, plus minus 0.8%. Okay, now let me. We look at what is full scale first. Can you, just now, which is the part that I asked you to figure out. What is the full scale output here? What is the full scale? Just now you all already told me, right? Full scale means you take the 255, right? Because it's the top already at the top. Full scale. So you take 255 times K, right? To give you the full scale. So let me write it down first. Now full scale, sometimes we write in short, you can put FS. Like this, full scale. Okay, maybe, yeah, we can do like that, full scale, FS. Okay, FS means full scale, over here. Okay, now, so what is full scale? So full scale is 255 times K. Okay, so it's 255 times 0.1, right? 0.1 milliampere. So what's the answer? Can you all help me? What is full scale? 25, right? You all say 25.5, right? Milliampere. So that means this is the maximum current it can supply. Max 25.5 milliamp. Okay. Now, so what do we do then? We need to find out what is this percentage, right? So what is the error? I need to find what is the error. the FS error, full scale error, full scale error, FS. FS stands for full scale. Full scale error equals to, so you need to, what is 0.8, right, over 100%, okay, times the full scale output, which is this one. 25, full scale output, 25.5 milliamp. So what is it? Can one of you help me? Okay, the full scale error, this is error. So I take 0.8, because I'm given 0.8% plus minus. So I find out what is it first. So I take 0.8% divided by 100% times 25.5 milliamp. 204. Is it correct? 204 milliamp or what? Micro. 204 microampere. Okay? You all got it? Anybody got a different answer? Or is it okay? So which means that this fella here can have a plus minus 204 microamp. Okay? So what is the possible range? So what do you do? Yeah, you will plus the value, right? And then the minus the value, yes, correct. Then it will give you the full scale. That means the output, the final answer, right, the range, they ask you for the range, right? Okay, I'm going to write here. So the range of possible value, range, will be equals to this 25.5 milliampere, right? Yeah, you just put like that, plus minus 204.
So we can convert, put 0.2 milliamp.
Can. As long as you give us in the correct units, it's fine. Okay, this one is microamp. So your 25.5 milliamp plus minus 204 microampere. That's your answer. You must remember, because you can have a plus, you can have a minus, right? Right? Because error can be more or can be less from the nominal value. Okay, so I worked through with you a full solution, full step-by-step solution for this particular question. Okay?
Will there be any additional question?
Can. Okay, one good point. Okay, additional question, maybe I can continue a part 3. Okay, now given the full scale error that you found already, right? Plus minus 204 microamp, I give you another digital value. For example, just now this value, right? I tell you what is the expected output value. Let's say if the same digital input, 138, right? So just now you all calculate the expected current is 13.8 milliamp, right? So that means 13.8 is not the final answer. There's a range. You understand? Actually, that's a good point. So that means this answer 13.8 milliamp, they have a plus minus. Because this one will have error. Everything is not perfect. So that means this 13.8 milliamp has a plus minus. What I should really write here is a plus minus. 13.8 milliamp plus minus 204 microamp. You know what I'm saying? There'll be, because there's an error. So you will introduce you will find answer for this one. But of course, it's not us in this question, but you all raise a good point. So that means the answer could be 13.8 milliamp plus minus. You know what I'm saying? 204. Okay, because nothing is perfect, right? So this, then you just subtract this one 13.8 plus 204, you give an answer, right? Then 13.8 milliamp minus 204. So you have a range already from lower to upper.
So the plus is on the upper?
Yes, correct. Plus it will be upper, then when you minus, it will be the lower. So your upper range, lower range. Yes.
This question mark is a 8-bit DAC, right?
Yes.
Is there like if 4-bit, 6-bit?
Too low. 6-bit too low. I will give you higher, not lower.
Higher
Okay.
than 8-bit?
Yes. So in exam, let's say for example, I can ask you a 10-bit. Okay. So please try to make sure your calculator can handle, or you know how to key in. Let's see if I 10-bit, how? If I give you 10-bit binary number, can you calculate? 10-bit. If your calculator cannot handle, right? Not to scared also, not to worry, because why? If it's 10-bit, can you also work out? If I give you a 10-bit system, let's say, Okay, this one 4, right?
We do separately or
Huh?
can we do separately?
Can. Let's say, for example, this lah. Okay, I give you a simple one. This one 8 bit, right? Right not? 8 bit. I add another one, add another 2 more bits. So how many bits are here? How many bits here? 10 bits, right? Can you convert this into a decimal equivalent? This one 10 bit, this one binary, right? Can you calculate in decimal? What is this in decimal number? What will you do? You can use the weights, right? Remember the thing that we learned? Okay. So this one, of course, is 2 to the power 0, right? Remember? 2 to the power. But all the zeros, you don't care, right? Because it's nothing, what? 0 means nothing, Right? 2, 0, 1, 2, 3, right? Right not? 2, 4. 2 to the power 5. You understand what I'm doing? This is the weights, right? The power, right? 2 to the power 7, right? Then 2 to the power 8. 2 to the power 9. Do you agree? Do you understand what I'm doing here? Okay, so I only consider this one only. I only consider these 3, right? So what I do is I will take 2 to the power 9 plus 2 to the power 8 plus 2 to the power 7. Right? So what's your answer? 896. 896 base 10. Okay? So same lah. Understand? So likely we will not give you like 6 bit, this kind of thing is too simple. Too simple. We'll give you at least like 8 bit. 8 bit, 9 bit, 10 bit. Okay? So can so this one make sure you are familiar how to calculate this one. Very important. Okay, I'll pause my